All right, on this one, I'm going to do it the long way first to just give you a nice reminder of really what's going on, and then we'll do it the short way. So with this one, it says simplify using the product property. What the product property says that if I have a square root of anything times it's something else, I can split this into their own little roots. So that's what I can do here. So what I'm going to do is I'm going to separate these guys out into perfect squares so I can simplify them. So 125 is 25 and 5. And then p cubed is the same thing as p squared and p. And then q to the fourth is the same thing as q squared, q squared. Now, I'm going to split these guys into their own little roots. So it's going to be the square root of 25. And I'm going to leave the square root of 5 inside its own root. I'm going to take this guy, make him his own root, so p squared. So this guy is going to come out as his own little root. I'm going to move this guy over because I'm going to need a little more room. So it's going to be this guy I'm going to keep inside because he's not going to simplify. And these two I can bring out. So this becomes 5. This becomes p, but remember, whenever we have the square root of a number squared, they reduce, but it becomes the absolute value of a. If you remember, it's because the squared is always going to make it positive. So if I stick in a negative or a positive here, it's always going to come out positive. And the only way to say that is by saying absolute value. So this guy is going to be the absolute value of p. And then this becomes q. And another q. Those are supposedly absolute value. And this is going to be 5p. So you end up getting 5p q squared square root of 5p. Now the interesting thing is that in our book, you look in the back of the book and this guy is an absolute value, this guy is an absolute value. There's two different reasons. This guy's not absolute valued because if q is getting squared, it's going to make him positive no matter what. So putting absolute value would be kind of redundant. And this guy is not absolute valued because if p is negative, this whole thing is going to be undefined anyway. So p is assumed to be positive because there's still a p inside here. It's a little weird, but that is why the answer doesn't have the absolute values when it should. Now, to do it the short way, what you can do, so I'm going to do the short way in red, you can pretty much factor everything. So 125 is the same thing as 25 and 5, and this is 5 and 5. So this is going to be 5, 5, and 5. And then you have 3 p's, 1, 2, 3, and 4 q's, 2, 3, 4. Remember the packages of 2 come out, so that guy comes out, this guy comes out, this guy comes out, and this guy comes out. So you have a 5, a p, a q squared, and then square root of 5p. Now, remember, if we are dealing with the square root and we're going to be doing this trick right here, you need to make sure that you put your absolute values. But once again, this one doesn't have an absolute value because you assume that it's positive because there's still a p inside. Now, if you look at the similarities between these two, the 5 and the 5 is 25. That's this guy right here. This package becomes this guy right here. This package right here becomes this guy right here. And if you notice, these packages of 2 reduce while the ones that don't have a package of 2 don't reduce. And that's pretty much why this trick works.